So then more things happened, and a place where AI was developed very rapidly and was being deployed successfully was NASA. So this is, I have some history because I interned at NASA as a graduate student, and also I was part of a field called AI planning, which was very central to NASA at the time. Maybe it's still today. So what are these applications? So for example, in 1998, there was a deep space mission, which was launched by NASA, whose job was to fly by some asteroid. Okay? And now, the remote agent system was a system which was supposed to manage this spacecraft. If a fault happens, this remote agent system will understand that there is a fault and it will correct it. So it was a diagnosis and repair system. And this was based on AI. Okay? And the AI researchers worked very hard to put this remote agent onto this spacecraft. Now, for most of the time of its space mission, it was operated and controlled by Earth. But for 3 days, in order to test the AI system, they said, let's give the control to remote agent. So let's have the remote agent control the whole spacecraft and let us see if it succeeds or fails. So the goal of remote agent is to identify any bugs and to correct them. Now they only gave control for 3 days. What happened? There were no bugs. The spacecraft did not make any mistakes. There was no problem. So nothing was supposed to be diagnosed. And if nothing was supposed to be diagnosed, it was very difficult to say that remote agent succeeded or failed. So in order to do that, they simulated some faults in the spacecraft. And so one of the faults they simulated was a failed electronics unit, which remote agent fixed by reactivating the unit. A failed sensor providing false information, which remote agent recognized as unreliable and correctly ignored. And last but not the least, a particular thruster was stuck in an off position. That is what was shown to remote agent, and remote agent detected it and compensated for it by switching to a mode that did not rely on that thruster. So in other words, remote agent did its job, but in a simulation on spacecraft, because in reality nothing bad really happened, but we are happy to take that as a success of AI. Because the fact that an AI system went as far as an asteroid is quite creditable and quite a success in those days. You have to go back to the days where AI had just gone out of the winter and things were starting to just look up very slowly. What I worked on in my internship was working on an algorithm for control of the rover on Mars. So everybody knows about the Mars rover, Spirit, Opportunity, Curiosity. There are many, many versions of the rover. And in the very first generations of the rover, there was almost no planning on board. I have been told that when you send something to, let's say, Mars, you can't send your latest GPU from NVIDIA and latest Intel CPUs. You have to test the processors for radiation, for this, for that, for shock, blah, 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 and you can only send the very robust and very heavily tested chips. So they were basically 10 to 15 years behind on what chips they could send to Mars. Okay? But nevertheless, earlier what would happen is that all the scientists will come together on a round table. They will say, what should my rover do today? Mars can contact Earth twice every 25 hours for 50 minutes apiece. So basically they will sit together, they will say, I think my rover should do this action, then this action, then this action, then this action. They will sequence all the actions, they will give it to software to make sure there are no issues with it, there are no constraints that are getting violated, and then they will upload it to the rover. Now the rover will start executing, but the rover doesn't know everything about Mars, right? It only observes something from the camera and its senses. So it starts to execute something, and it suddenly identifies a small piece of pebble or something which it did not know existed earlier. So at that time, the sequence did not incorporate for it, right? Correct for it. So the rover says, okay, I'm asked to go straight, but there is a small ditch. I should not go through the ditch. So what should I do? I don't know. I'm an expensive piece of equipment. Let me stop. And the next time I can contact Earth, I will tell them there is a Gaddha, what should I do? And so then all the scientists will come together, will say, oh, there is a Gaddha. Let us have the rover go around it. So they will again write everything, manually. They will sequence all the instructions, make sure everything is verified, and upload it. Next time. Then the rover will start executing, it will see another Gaddha. The point of the matter is, most of the time rover was sitting idle. Right? Now what's a simple solution for it? Give the rover some ability to plan on the device, on board. It should not be asking every little thing for scientists from Earth. And moreover, the scientists from Earth should also not be, sequencing everything manually. They should have a software which is giving them the plans, which a planner is producing. And so this planner was devised by an AI researcher working at NASA at the time. An or a team of course, there's always a team. So they created a software. And that software was supposed to, given a goal which the scientists would decide that, okay, you should reach that rock or you should do that experiment with the rock, the planner automatically will generate the plan, and then it will give to the human scientist to say, okay, now you figure out, is this okay or not? Now, when they created this software, the first reaction of the operations people was, how do I trust this AI system? My rover is a multi-million dollar at least piece of equipment. I cannot get the rover make mistakes. And if your AI system makes a terrible mistake, then we will be hosed. And so it went on and on because the operations people did not understand what is happening inside the AI system. They did not trust it. And by the way, this notion of trust is going to stay with us in the course, and towards the very end of the course, we will talk about ethics of AI, where trust and transparency are extremely important and is a major issue today in the modern AI system. So the best this NASA scientists could say is that A, there is this button. As soon as you press the button, the planner will be turned off. It will no longer sequence anything for you. You can still do everything manually. We have given you full autonomy. Let us get the software to you. Let us put it on the deployment setup. And then, if you want to turn it off, you can always turn it off. And moreover, it will do all the constraint management for you. So at least the constraint parts you can trust that it will do, because it is just doing some basic checks of whether all the safety constraints are satisfied or not. So operations people finally bought it. They said, okay, we will turn it off if you are not satisfied. And at least for the first few years, they did not turn it off. And so that was, I don't know today, what is the status. I have sort of lost touch with them. But I do know that, for the first few years, they were now regularly using the AI planning system for doing the control of rover. And later, they started giving rover some motion planning on board so that it doesn't keep waiting all the time. So all of those things have started to happen. Hopefully, the latest versions are even further along. So this was another success of AI, because after coming out from a time where AI was considered a bad word, we suddenly had AI systems working in NASA and getting deployed in real missions of importance. However, we still did not reach you and me. NASA, chess, these are very sort of specific and niche areas, but it did not touch lives of people at large, still. Okay? And so in 2005, one other major event happened. And this you must already know a little bit about, and this was the DARPA Grand Challenge. You know about DARPA Grand Challenge? This was the first working demonstration of a long trip taken by a car completely by itself. Now we talk about driverless cars. Everybody knows about driverless cars, right? But you have to realize that this driverless car and this Tesla cars and so on, this auto drive feature and right? All of these features that we have, they have a long history of research. And even before 2005, there was a long history of research. But in 2005, we had the first working demonstration where DARPA thought that we are ready and created this challenge where 220-mile stretch, I think, approximately, of the Navajo Desert in Nevada was to be traveled by these cars completely automatically, with no manual control. There was not a single human sitting in the car itself. You can follow it so that you know everything is safe. You may have a control at the end saying that, okay, stop, you're doing something crazy. But the cars were supposed to drive it completely, automatically, autonomously. Not 220, 132, sorry. And there are stories after stories after stories about this, because this was a huge event, and when this got successful, I mean, everybody was really amazed and excited as to the possibilities of the future. One of the very interesting stories is that the team that was supposed to win this competition and the team that actually won the competition were two different teams. So does somebody know who won the competition? Which university? No, you guys are too young for this. So Stanford won the competition, and it was won by Sebastian Thrun's group. Professor Sebastian Thrun at the time was a professor at Stanford. Later he started Udacity, and and he was the first person to teach an online AI course along with Peter Norvig. Peter Norvig is the co-author of the Bible that you have, right, of the AI book. So if you think about it, AI course was the first course which was done in an online fashion, and 100,000 people registered for it. And some 5,000, I think, finished it, or 10,000 finished it. Again, I have to check the numbers, I don't remember. So the fact that suddenly your AI course, which you were teaching to Stanford students, was taken by people from all across the world, people who may be working in industry, people who may be single moms, people who may be working moms, people who may be, old people who just want to learn about, everybody took this course, okay? And then there were people who completed the course and went on to, increase the quality of their life by getting the next job. That opened the eyes of all academicians to the possibilities of online courses. And now you guys don't even attend my classes because you know that, you can go online and check out the course content that you are interested in. So I have to make my classes funnier and funnier so that you attend. Right? So this all started because of AI course. And the person who started this was Sebastian Thrun. And Sebastian Thrun went on to form Udacity, which was an online course platform. And its competitor later came to be Coursera, or I don't know which one came first. And then they competed, and then, we sort of know which is more prominent today, and Udacity sort of took a different role, and so on. But there is more interesting story about how Sebastian did it and why CMU lost. And, okay, I'll spend 2 minutes quickly telling you some of those very nice nuggets of, history, trivia. For example, Sebastian did not have a long history of doing driving cars, self-driving cars. He got a team of undergrads together with researchers and postdocs. A lot of the work was, believe it or not, done by undergrads. Not unlike you, maybe in their 4th years, I don't know. And they all worked on this thing day in and out, and of course they got a car and they started instrumenting the car and they started putting in the sensors, blah, blah, blah. But they also did not have a long history, and so they could use some of the more latest algorithms, and they could develop some more interesting probabilistic reasoning algorithms to identify where exactly they are in the big picture, because they were, you had to localize yourself, you had to understand what the terrain is in front of you, etc., etc. There were a lot of questions to be solved, and very interesting AI work came out of this particular exercise. Their team was called Stanley. Now the team that was expected to win, however, was CMU's team, led by Professor Red Whittaker, who was very, very famous for exactly self-driving cars. He had a long history, years of history of building driverless cars and working on the technology for it. He did not have one entry in the competition, he had 2 entries in the competition. One was called Highlander, one was called Sandstorm. And the 2 cars were very different. Sandstorm's job was to just follow the leader and come second. Now, I can't exactly understand the rationale, but it is what it is, right? They probably wanted to make sure that one of their participants finish the competition. because eventually only 4 teams finished the competition. So, Sandstorm played a perfect race. It kept following the leader and came second. Now, the car that was expected to win was Highlander. And believe it or not, Highlander started having engine trouble. To the extent that at some point it is said that the Highlander will go forward, come back, go forward, come back, go forward, come back. And it was stuck. And finally, Stanley carefully overtook Highlander and ended up winning the competition. And Sebastian got a lot of press. It was an underdog win story. But nobody knew what happened to Highlander, including Red Whittaker himself. Red Whittaker said, let bygones be bygones, chucked Highlander into the garage, made a new car, and won the next competition, which is called the DARPA Urban Challenge, where the cars had to drive streets and roads in the city where there could be people, because on the desert there were no people. Right? So then, for 12-year anniversary, I believe in 2017 or whenever they were having some fun, or maybe 2019, they got the car back from garage, cleaned it up, and in the process of cleaning figured out what went wrong. They realized that there was a filter which was connecting the engine control module and the fuel injectors. And if you touch the filter, it stopped working. And if you removed any touch from the filter, it will start working. That's it. There was this one, not even, I believe, an electronic component, or maybe it was an electronic component, I don't know. There was just one component that went wrong, and they lost the competition. Nobody really talks about Highlander and the fact that they won the DARPA Urban Grand Challenge, because the first demonstration is the first demonstration. If you win, if you are first to do something, you are the leader. If you are the second to do something, good. Think about this. So that's where in research, you can do research where you are the first to do X, or you can do research where you are the second to do X and you do better than the first. And while if you do better than the first, and eventually if you can make a product, you can make millions. But if you want fame, you have to be the first to do something. Like the first to do demonetization. Okay, that's a bad joke. But the point stands, right? So, good. So, let's move forward. And that led to Sebastian Thrun going to Google and tech transferring that technology to Google. So Google worked on self-driving cars for a long time before finally Tesla also benefited from that kind of work. And we have a Tesla cars which have automatic control feature. And you must have seen some of these videos where the car makes a decision to stop because there's an animal coming in. And if you see something bad happening, like this car on the left is coming to the right, then you go on the shoulder, and so on and so forth. And this is all automatic driving capabilities, and in the night it is also pretty awesome, particularly because humans can't see, but it can sense through its laser finders and so on. Okay. So I'll move forward. So now we have come to 2010s, and IBM's Watson has happened. IBM's Watson, so again notice how important IBM has been in this whole picture, because IBM has a long history of building big AI systems, and the next big AI system they built was their Watson system, where the Jeopardy player IBM Watson defeated Ken Jennings and another contestant who were the well-known world champions in Jeopardy on answering Jeopardy questions. Okay, I have a video, but I don't think my audio is hooked up, so I'll just skip. But you can check this video link on your computers. Basically, Watson quickly answered questions. Any question you throw at it, Watson would answer faster than Ken Jennings. In the end, even in the real thing, Watson ended up getting $77,000, and Ken Jennings said, "What is going on? I have defeated every human who has come to Jeopardy, but this is too much for me." And finally, he says, "I welcome our new computer overlords," a reference that comes from Simpsons. Okay.